In our next video, we're going to be looking at objectives 2 through 5 from section 1.7, and because there are a bunch of different properties, or you might think of them as rules, that apply when we're doing math. The commutative property is the first one, and the commutative property, there's a commutative property of addition and there's also a commutative property of multiplication, and both of them say changing order doesn't change your answer. So in your homework set, you're going to be asked to be shown how the commutative property works with addition and with multiplication. So the way that I would do that is to say that if I changed the order of 2 plus 29 and wrote it as 29 plus 2, those answers would come out to be equal or the same. That 2 plus 29 is 31 and 29 plus 2 is also 31. The same thing is true of multiplication. So in this example, I have m times 10. That's the same thing as 10 times m. And as I said on the previous page, we usually don't use an operation symbol in our multiplication. So this would be more traditionally written as m10 or 10m. And as you look through algebraic expressions, you'll start to notice that the constant, which is the number that stays the same, 10 always represents the same amount of stuff, goes in front of the variable, the number that doesn't stay the same, that varies from one problem to the next. Our next property is the associative property, and just like above, there is an associative property of addition and an associative property of multiplication. Okay. Both of these say that when you change grouping, so an associative property problem is always going to have a grouping symbol in it. If you look over here, you can probably guess that our grouping symbol here are pairs of parentheses. That if you change grouping, doesn't change the answer. So in this one, the parentheses, if we were following order of operations, would say that we need to multiply the negative 5/8 times 2/7 before we multiply by 7/2. Well, the associative property lets us make a change to that. It says that we can move this grouping symbol as long as our operation is multiplication, because we have an associative property for multiplication. So since this means that all three of these fractions are getting multiplied, we can change our grouping and multiply these two fractions first. And the reason we would want to do that is, as you can see, they're going to reduce down to a 1. And multiplying 1 times the negative 5/8 gives us negative 5/8. Had we done the problem as it was originally stated, the only thing we could reduce was the 2 and the 8, and then we'd have to do reducing a second time when we multiplied by the 7/2. It can also help us when we're doing addition. These three characters, the y, the 12, and the 3, or these three terms, are all being added together. But they haven't told us what y is worth, so we don't have a way of adding it to 12. So I'm going to change these grouping symbols and group the 12 and the 3 together instead, because I can add a 12 and a 3. So 12 plus 3 would give me 15. And then, since I haven't been told what the value of y is, I just leave my final answer to this, y plus 15. One final note on these two properties before we move on. Notice that there is a commutative and an associative property for addition and for multiplication. There is not no associative or commutative property of subtraction or division. Okay? When you change the order of your terms in a subtraction problem or a division problem, you do not get the same answer. You get a different answer. So you can only use these changing grouping and changing order rules when you're dealing with multiplication or addition. Our one final definition to go through on this particular page is the identity property. And I remember this one as the identity property of addition says adding 0 doesn't change identity. Okay, doesn't change the value of any number. Likewise, the identity property of multiplication says that multiplying one doesn't change the identity or value. Okay, so examples of that, this first one is a multiplication problem. If I take 9, the only number I can put in here that will make 9 stay 9 is a 1. When I multiply 9 times 1, it stays 1. So we call 1 is the multiplicative identity. And the same thing over here. If I want to add something to 3.8 and have the answer still remain 3.8, the only number I can add is 0. When I add 0 to something, it doesn't change the value. So 0 is the additive identity.